Okay, so these are going to be the notes for the graphs of logarithmic functions. So I'm just going to kind of read through this and we'll talk about how to actually do this. So it says, how do we graph logarithmic functions? We use the fact that a log function is the inverse of an exponential. This means that the logarithmic function reverses the coordinates of the exponential function. So in essence, all you do is you find the exponential, you switch x and y, and you create the inverse, and that's the logarithmic base, or the logarithmic table. So let's go and take a look at this. So example 6 says graphs of exponential and logarithmic functions. So we have f of x equals 2 to the x, and we have g of x equals log base 2 of x. Now, if you have a graphing calculator, you could simply just type that in and get the table, but we don't, right? We have a scientific calculator, kind of like that. All right, so we've already done this before. So we're going to take 2 to the x power, and just like we did before, we're going to raise it, right? So we're going to start with 2 to the 0 power. What's 2 to the 0 power? 1. What is 2 to the first power? 2. What is 2 squared? 4. Now, do y'all recall what we do when it's a negative power? We flip it over. So this 2 becomes 1/2. The 4 becomes 1/4. Now, if you paid attention when I said the graphs of logarithmic functions, well, it said that they are inverses. So we just covered inverses, and in Algebra 2, you may have covered the inverses given a table. So to find the inverse of the exponential function, which is the log, all you have to do actually is switch the x and y's. So what does that mean? We're going to take these y values, 1/4, 1/2, 1, 2, and 4. We're going to make those our new x values. And our x values from the exponential function become our y values for the log function. And this inverse table is actually the log function table, okay, with the base of 2. So I can actually check these points in this little graph I'm given. So let's check if 0, 1 is here. So here's 0, 1, or sorry, 1, 0. 1, 0 is right there. I have 2, 1, and then I have 4, 2. So you see how they line up right there nicely. So it does work. All you gotta do is just switch those values and you get the inverse, which is the log. Questions? All right, yes, oh, sorry. All right, let's try this next one here. F of x equals, and I think there's a just an x missing here, so we're gonna put it should be 3 to the x power, so if you don't mind, fill that in real quick. 3 to the x power. Oh, sorry, thank you. Okay, so we have 3 to the x power. So again, we're gonna raise them all to the powers, and we'll see what we get. So what is 3 to the 0 power? 1. 3 to the first power. 3 to the second power. 9. All right, when we have the negative 1 power, so what's 3 to the negative 1 power? 1/3, and what would this one be? 1/9. All right, questions? Okay. All right, now that we have this, how do I find the table for the log function? Who can tell me? What do I do? Switch the x and y, there you go. So my x values, -2, -1, 0, 1, and 2, those become my y values. And the 1/9, 1/3, those become my x values. All right, and there we go. There's our table. Now, in terms of this, we're gonna graph it, but I believe for the most part, when we do quizzes and tests, we only have you make the tables because making the graph does take extra time. Now, what I'm gonna do is I'm just gonna graph this log function, and it's an estimation, right? Because 1/9, I have no clue where that is, but 1/9, let's say it's right here at -2. 1/3, -1. We have 1, 0. We have 3, 1. And then we have 9, 2. Now, if you recall from Algebra 2, or if you think about the inverse function, the exponential function has a asymptote on the x-axis. For the logarithmic function, your asymptote is actually the y-axis. So it's like an upside down L. That's the shape it makes. Hopefully y'all can see that. I know it's a little lighter than I should. I should probably use red, but there you go. Any questions on that? All right, pretty easy. And really, once again, my main focus is going to be making sure you get these tables right. That's what I'm looking at. No, the main focus for y'all should make sure you can do the tables. That's very important. All right, let's go to the next one. All right, okay, so this right here is just the transformations. Again, we always focus on that letter C right here. So very important with these because you see how the second set has parentheses and the first set does not, right? What I like to do is get in the habit of just putting parentheses around the x only so I know where those parentheses are. So when it's on the outside, if it's plus the number, it goes up that many units. If it's minus, it goes down that many units, right? So like this affects y, either plus or minus to c. Here, we're affecting x. What are the transformations when it's inside the parentheses with x? Y'all remember? If this one goes up and down, what does this one go? Left and right, right? And it's the opposite of what you see, right? So this one is going to go left C units, and there you go, so these left C units, and this one goes right C units. So just remember this one affects your x. Now the reflections, just like the exponential, if it's on the outside, it reflects across the x-axis, and if it's inside, right in front of the x, it reflects across the y-axis. Now your vertical stretch and vertical compressions, those are going to be your C value. Again, if it's greater than 1, it's a vertical stretch. But if it's less than 1, greater than 0, that's your vertical compression. And the horizontal ones would be any constant being multiplied to the x. We would just flip it over and follow those rules again. Okay. So let's do a couple of examples on this, and then we will keep going. All good here with the transformations? All right. So for example 6, it says log base 2 of x and g of x equals log base 2 of x plus 2 in the same rectangle. So we're going to graph them, but really, if you notice, we're just making the table. That's it, nothing else. All right, so we're going to start with this 2 to the x power. Can somebody tell me the values that go starting here? 1, 2, 4. Okay, what about here? 1/2, 1/4. Nice job. So those are our values. Now, to get the logarithmic function, what do I do with those points? Flip them. So what are my new x values? And my new y values? Good. Okay, now this is the part where you're going to start applying those transformations, right? So take a look right here. Inside we have x plus 2. What do you think that transformation is? Always the opposite of what you see. So it is left 2. So right here it's left 2. Does left 2 affect x or does it affect y? It affects x. So my rule, I'm going to put that on the outside. It's going to be very at the edge right here. It's going to be x minus 2. And are the y values affected in any way? No, so it's just y. So with the y values, I'm going to just write those over. So we're using this table right here. So my y values are going to stay -2, -1, 0, 1, 2. Now, to my x values, again, if you're not comfortable doing it in your head, put them in the calculator. I'll start with this 1/4. We're going to take 1/4 and we're going to subtract 2. So let me try this calculator. And either fraction or decimal, preferably a fraction. So I'm going to do n over d, so 1/4. And then I'm going to subtract 2. And I get -7/4. And I'm going to do the next one. So 1/2. And I'm going to take away 2 again. And I get -3/2. Now from here, the numbers become whole numbers. So right here, what's 1 minus 2? -1. What's 2 minus 2? 0. What's 4 minus 2? 2. And there is my logarithmic table for the transformation of left 2 units. Let me know if you have any questions on that. Pretty easy? Hopefully. All right, leave it up there for a moment more, and then we'll go to the last few problems. All good? All right, so let me move to the last few problems here. I'm not sure how many are left. We have several. Okay, so let's take a look here. Okay, so right here it says graph ln of x and g of x, which is ln of x plus 1, in the same rectangular coordinate system. Again, like I said, we're just looking for the table. So this is our e value now, right? Okay, so be careful on this one. So we start with e to the 0 power. What's e to the 0 power? 1. What's e to the first power? E. What's e to the second power? E squared, right? So that's pretty simple. It's just, it is what it is, what it comes out. Now, when we raise it to the negative exponent, what do? You flip it. So what would this one become? 1 over e. What would the -2 be? 1 over e squared. All right. Who can tell me my new x values for the inverse? 1 over e squared. 1 over e. Nice. Y values become my old x values, so -2, -1, 0, 1, and 2. So now we have our ln function here. All right, now we're going to take a look at the transformation here. If I'm going too fast, let me know. But who can tell me that transformation? Looks just like the previous one. Left 1. All right, so it is left 1. What does left 1 affect? X. So what would be the rule for x? X minus 1. Are the y values affected in any way? No, so it's just y. All right, so I go back to this table again, right? We're looking at the ln one that we just made. So for my y values, they don't change, so let's write those first. -2, -1, 0, 1, and 2. Can y'all tell me how to write my new x values if it's x minus 1? Who thinks they know how to do that? Close. 1 over e squared, and then what do I do? -1. There you go. That's all you have to do. You take it and you just actually subtract 1. So what would be my next one? 1 over e minus 1. And now we get to the actual numbers. What's 1 minus 1? And then we're back over here. E minus 1, and there you go. Questions? All good? All right, we're down to the last, is this the last example? All right, here we go. Okay, so this one right here, it says 2 minus log of x. All right, so unfortunately, I can't really see anything here, so let's go ahead and put the base. What's the base there? Now, notice there's no base, right? So what's the base if there's no base? The base is 10. So right here, we're going to do this one as y equals 10 to the x power. So let's start with it. What's 10 to the 0 power? 1. What's 10 to the first power? What's 10 squared? 100. All right, over here, we flip them over. This becomes 1 over 10, and this one is 1 over 100. All right. Who's going to give me my new inverse table? So this is going to be y equals log of x. So what are my new x values for this one? 1 over 100. 1 over 10. 1, 10. Nice job. What are my new y values? Good. All right. Now I'm assuming the last one, they want this equation right here, y equals this one, 2 minus log of x. Now, there are two transformations. You got to be careful here. First off, that 2, what does it do? It's actually a k value. It's a positive 2, so what does it actually do? So let me rewrite it so you can kind of see it a little bit better. Because now on a quiz or a test, we'd probably write it like this, but you got to understand it. It's actually something like this. Y equals negative log base 10 of x, and on the outside, plus 2. So what does this actually do? Goes up to, there you go. So you got to be able to see it. You rearrange it, you see it a little better. What does the negative in the very front of the log do? Reflects across the x-axis, that's correct. All right, now, do either of those transformations affect your x values? No, they don't, right? So my x values actually will not change. Now, the reflection across the x-axis, you make the y's the opposite. So we're going to do negative y. And then up 2, we're going to add 2 after we reflect it. So those are the two rules right there. X does not change, but my y values, I'm going to multiply by -1, and then I'm going to add 2. So this is nice because these x values right here are fractions, so I don't have to worry about them. I just rewrite them. So 1 over 100, 1 over 10, 1, 10, and 100. Now, really quickly, when you're doing these y values, if you want to do them mentally, by all means, go for it. But you do have the calculator available, so let me show you what I would do in the calculator. So I'm going to start with this -2, right? So I have negative, and then we have -2, and then close parentheses, and then we add 2. And that's going to give me 4, right? So notice I just typed into the calculator. I got the answer of 4. The next one, negative parentheses, negative 1, close parentheses, add the 2. What do I get here? What do you think? 3 is correct. And hopefully at this point you start seeing the pattern. What's the next one? Negative 0 plus 2 is 2. Look at the pattern. 4, 3, 2. What comes next? 1 and 0. All right, so that's all the notes for today. If you like this video, make sure to hit that like button. And don't forget to subscribe.